Hello friends, today we'll discuss the next topic, that is a mesh current analysis or Kirchhoffs voltage law. With this method we can find the current in different parts of any circuit. This is a circuit in which we'll find the current in the different mesh, like this is the first mesh, this is the second one, and this is the third one, and we have to find the current in all three meshes. The three independent mesh currents I1, I2, I3, I1, I2, I3, uh, as shown in figure number 1. Here we will apply the KVL in three meshes. By inspection method we can write the mesh equation in matrix form by some kind of practice. The first step to apply the KVL or mesh analysis is, firstly we'll consider the three loops. In this circuit there are three, it can be three, two, or more than three. We will take the mesh current according to the number of meshes available in the circuit. For example, this one we have a one, two, and three different meshes. We'll consider the three different mesh currents like I1, I2, I3 in clockwise direction. We'll take the direction of current arbitrarily. We have considered in clockwise. You can take anti-clockwise also, but here we have considered the each mesh current in the same direction, that is clockwise. Let us consider the first loop. As we know, the current should start from the positive terminal and uh, complete path to the negative one. Uh, the voltage drop in resistors will be always taken as a negative. The voltage of voltage source can be taken positive or negative depending upon the direction of current. If the mesh current is flowing in such a direction so that from the positive terminal of voltage source current is uh, giving outside, then it will taken as a positive. And if the current of the mesh is entering in the positive one, then it will consider as a negative. Like for 20 volt we have considered the clockwise direction, the current will leave from positive terminal, so that is the positive source. While in case of mesh number 2, I have taken the current in the clockwise direction. Here current enters in the positive terminal, so that's why this is a negative, because as per assumption the current will leave from the positive terminal and enter in the negative side. That's why this is 10 volt will taken as a negative. We will write the equation for the mesh number 1. So from mesh 1 is this one mesh 1, so we'll start taking on this one. So current is in clockwise direction, so current will leave from positive terminal, current will leaving from positive terminal, or current will start from positive terminal. So this will taken as a positive, so we have taken 20 as a positive. Then there is some resistances, 1 ohm, 2 ohm, and 3 ohm. All the drop in the resistance will taken as a negative. In this resistance R1 the current will only flow I1, so this will be I 1 into 1. So there is simple formula, V is equal to I into R. The resistance of R1, the current will be I1, so I1 into 1 ohm. After that, this is the R2. Here the current I1 and I2 both will flow, but we will consider the I1 as a dominant, hence we will take I1 minus I2. For loop 1 we will consider I1 as a dominant, for loop 2 or mesh 2 we will consider I2 as a dominant, and for mesh number 3 we consider I3 as a dominant one. So hence in this 2 ohm resistance current I1 and I2 both will flow, but we will consider I1 minus I2. V is equal to I into R. So R is 2 ohm and I is I1 minus I2. Similarly for third one there is a I1 minus I3, because here is I1 and this part is I3. So here current is I1 minus I3. So that will be the equation, KVL equation for the mesh number 1. And this can be written like this way. Here we have just taken 20 at the different side, and the equation will look like this one. Now we have arranged the equation in such a way so that I1, I2 and I3 and is equal to constant. Here it is very important, we'll take care that I1 current coefficient 6 should be positive. Testing can be anything, but this should be as a positive. Here 6 I1 minus 2 I2 minus 3 I3 is equal to 20. Similarly, we can write the equation for mesh number 2. This one here, if is a resistance and then drop to minus 2 I2 minus 7, because we are writing the for mesh number 2, so I2 current will taken as the dominance. Here the current will I2 minus I1, so minus 2 I2 minus I1. Once again, there in R4 resistance only current I2 will flow, so minus 2 into I2, minus 2 into I2. After that, there is a 10 volt of the voltage source, but I have taken the current in the clockwise direction, and current will enter in the positive terminal. That's why this source will taken as a negative, the minus of 10 volt. After that, this is a 1 ohm resistance, that is R5, and the current will I2 I3 both will flow, but we'll consider I2 minus I3 because I2 is a dominance. So minus ka 1 I2 minus I3, we will take the direction in such a way. I will say that we will consider, because we are writing the equation for mesh number 2, so current I2 should be positive, the coefficient of the I2 should be positive, plus 5. Anything can be different, like I1, I3, and this can be anything, but we have to make this particular current, that I2 should be positive. Minus 2 I1 plus 5 I2 minus I3 is equal to minus of 10. Similarly, we can write the equation for mesh number 3. Here we have to take care the coefficient of the mesh number 3 should be positive, like I3 5 plus 5. So we have written the equation of mesh number 1, mesh number 2, mesh number 3, and we should take care that for mesh number 1, I1 should be positive, for mesh number 2, I2 should be positive, and for mesh number 3, I3 should be positive. So that this is a matrix representation. What we have write the equation, we can write in the form matrix. This is the equation that we have already written for the three meshes 1 2 and 3, 1 2 and 3. That is equation matrix. R into I should be equal to V. So V is equal to I, that simple Ohm's law, and we can write from there. So here R I V. So R is a resistance, I is a current, V is a voltage. So that is the first one. The first I1 current will flow in the R1. You can see from this particular diagram, this I1 current will flow R1, R2 and R3. It can be added R1 plus R2 plus R3, like this way, R1 plus R2 R3. I1 current will flow also in the basically the I2 current will flow in the 2 ohm, and the I3 current will flow in the 3 ohm. These will be resistances that will be taken as a negative. And similarly, we can write all kind of three equations. uh, we can write this matrix with the help of this particular one. It will be very easy to write you, like look here, uh, here 6, it is 6. You have to just take the coefficients. 6 6 minus 2 minus 2, and then minus 3, and then is 20. So we have just make this particular equation in the matrix form, so this can be written in this particular format. That's why I am saying that for mesh 1 I1 is positive, mesh 2 I2 positive, and mesh 3 I3 positive. So this equation can be written in the matrix form, and with the help of Cramer rule we can solve one. The determinant of this matrix will be called as a delta. Delta will be calculated by the simple rules, and this can be 67. The determinant of this matrix will be delta. Similarly, we can find the delta 1, delta 2, delta 3. This is a determinant of class नहीं थी ना? नहीं मैं बात नहीं थी. We can take the delta 1. Delta 1 is simply we can replace the first uh, column of this one with the help of voltage 1 to 20, 10 and 0. Similarly, delta 2 will be, we can replace the second column by the voltage 1. And similarly, delta 3 is we can replace the third one with the help of this one. So we can find these deltas, delta 1, delta 2, delta 3, and by the Kramer's rule we can find the current one. Current one I1 is equal to delta 1 upon delta and similarly I2 will be delta 2 by delta, and I3 will be delta 3 by delta. In this way we can find the mesh currents I1, I2, I3 as a 5.224 ampere for the I1, 0.7463 for the I2, and 3.28 for the I3. These are the currents you can find with the help of. And, thank you for listening in the next lecture.